Okay, today I'm going to present my research topic on characterization. One second. Yeah, today I'm going to present on my research topic. It's a part of my research topic, that is the characterization of biosynthesized silver nanoparticles from an endangered fungus. That is the Alternea alternata, which has been isolated from an endangered plant. What I selected is the Mapia foetida and its antibacterial activity. Okay, today I'm going to present about the nanotechnology. The introduction part. Usually we all know the plants have served as a source of medicinal bioactive compounds, where it has been used for many treatment of certain diseases. As we all know, the plant extract has been used for treatment of many diseases, but here the new thing what I focused on, the endophytes which are present inside the plant, which can act as an treatment. Okay, usually the endophytes can be found either in the plant species, which includes bacteria and fungi. The term endophyte was coined by the German scientist, that is the Heinrich Anton de Bary, in the year 1884. Endophytic microorganisms are said to be a promising application in the development of the drugs as well as some of the industrial products. Okay, in this study, the main aim is to examine the endophytic fungal diversity as well as the nanoparticle characterization. Okay, here the plant selection, what I've selected in my research is the Mapia foetida plant, that is an endangered plant. Usually this plant belongs to the families Icacinaceae, that is also called as Amruta Kalgur, and it has an anti-cancer properties, which has made it them as an endangered species. The profit potential is an enormous alkaloid compound. Here the alkaloid compound which has been present is the camptothecin. Okay, this camptothecin which acts as an alkaloid, and hence its alkaloid can act as an in the treatment of cancer disease. Okay, this is the plant which I have selected, especially from the Western Ghats region. Okay, this is the complete classification of the endangered plant, that is the Mapia foetida, and we call it as Nothopodites pneumoniana. When it comes to materials and methods, first I have selected the plant area, that is then followed by the plant collection, then isolation and morphological identification of an endophytic fungi, followed by diversity analysis of the endophytic fungi, and at last I gone through with the in vitro activity of the silver nanoparticles using fungal extract of Mapia foetida. Okay, when it comes to the result, we have collected the plant. Once the plant has been collected, we have gone for a certain sterilization techniques. Once the sterilization is done, we have inoculated the plant to the certain media that we have used here is the potato dextrose agar media. And here we have found around 20 different endophytes. So you can see in the picture. Once the endophytes has been found, then we have gone for the synthesis of the silver nanoparticles using the endophytic fungal extract. So here we can see the endophytic fungal extract has been changed in color. That is the Alternea alternata main thing that we have used, that is yellow to brown, for the synthesis of the silver nanoparticles. Once the synthesis of the silver nanoparticles has been done, we are gone for the certain characterization, that is the UV spectrophotometer. Here, the UV spectrometer has been done. Here, this shows the optical properties of the silver nanoparticles, which are related to the excitation of the plasma resonance. Usually, we can see the time interval, that is 5 minutes to 1 hour, where you can see the increases in the peak absorption. Then followed by, we have gone for the zeta potential analysis, is a second kind of characterization. Here, this predicts the long term of the particles. Here, the zeta potential can be shown in the, that is minus 12.3 megavolt. You can see in the graph. Then followed by, we have gone for the scanning electron microscopy, where the nanoparticle has been seen in the nano size, that around less than 100 nanometer. Then followed by the X-ray diffraction. The X-ray diffraction can be used with the 5 intense peaks, where the nanoparticle can be clearly observed. Okay, followed by we have gone for the certain antimicrobial activity, whether the nanoparticle will be resistant to the microorganisms. That is, especially we have used here 3 gram positive bacteria as well as the 3 gram negative bacteria. Based on the result, we have got the negative, that is the gram negative bacteria had shown the good resistance power with the nanoparticle. Then finally, this silver nanoparticles can be used for the production of the drug analysis, especially in the treatment of cancer diseases. So finally, I conclude the green synthesis of the silver nanoparticles was studied, and the formation of the silver nanoparticle was identified in the color change, that is the yellow to the light yellow. Then UV spectrophotometer showed the optical properties of the silver nanoparticles, which are related to the excitation of the plasma resonance, as well as zeta potential showed around minus 12.3 megavolt, and the SEM, that is the scanning electron microscope, was also identified within the less than 100 nanometer. Then the main application of the silver nanoparticle is an antimicrobial agent, and it was investigated and exhibited better antimicrobial activity against the pathogenic microorganisms. So finally, I conclude that from our study, we can conclude that silver nanoparticles could be considered as an excellent spectrum as an antibacterial agents. Okay, thank you.